Hey guys, it's day 2, which really is this last day of our little complex unit, other than our practice day. So the idea for today is now that you know how to use powers of I, we want to be able to do all sorts of different operations with them. So multiplying, adding, subtracting, dividing, you get the deal. All right. So let's write ourselves that little note at the top to start. So now that we know the powers of I, and how to simplify, we can simplify radicals with negative, all right, get ready for a bonus word here, radicands. That's just a fancy way to say the number underneath the radical. So the key, remember, we said that I is equal to the square root of -1. That is the definition right there. That's key. Otherwise, we can't go any further with this. So for simplifying these, we're just going to rip through a bunch of examples just so we can kind of show what's going on here. So very first one, if I give you the square root of -7, right? Typically, I would say it's any square root, break it up into the perfect square times the leftover. There is no perfect square here, but at the very least, you can split it apart so that you have the number and then the negative as a -1 separate. In this case, there's not much to do with this radical 7, but that is going to turn into I. So you can write it like this, or sometimes I'll put the I in front of it. Just make sure that when you write it, you're not putting the I underneath there with it. So you have to make sure it's super clear that these are separate and that I does not go underneath here. All right. So I'm even going to put an X through there so you don't get confused by it and try to do something with it. All right. For this next one, if I give you square root of -12, simplify it. You got to think, what perfect square goes into 12? Of course, 4 is the answer. So 4 times 3 would be the leftover, and then separate out that -1. So we're really breaking it into 3 parts, which is perfectly fine, right? Square root of 4, that turns into 2. Radical 3 we keep. And then the square root of -1, that turns into our I here, right? If you would prefer, you can put it as 2I and then radical 3. It really doesn't matter to me. The only time maybe somebody could be picky about it is if it said write it in A plus BI form. And in that case, it'd be 0 plus. Technically, the B part would be the 2 radical 3 and then the I on the end. I'll tell you this, I don't care which way you do it. I just don't want to see the I underneath the radical. Okay? So whichever you prefer sounds lovely. And so I should probably box in that last answer. All right. For number 3, you could be given something where we're then adding the radicals. Right? For something like this, you always want to simplify first. And in this case, you're probably already recognizing that, hey, that's a perfect square. That's a perfect square. This is going to come out pretty nice looking. So you would break this and that just into the perfect square and then times the -1. So here we would get 5I. Here we would get 7I. We're adding together. The i's you would treat just like x's. So if this was 5x plus 7x, you'd get 12x. So if it's 5I plus 7I, oops, I didn't mean to write the 5 again, then it would be 12I, just like that. All right, so you treat it like any other variable. So a little note to self, simplify the radical first, and then combine your like terms. Ta-da, that's it. All right. Can we make it slightly more complicated? Of course we could. Sometimes you're going to get combination ones where you've got just a single real number and then maybe a radical and then maybe another real number and then maybe another radical. There's all sorts of fun stuff we can throw at you. So for something like this one, simplify the parts that you can. All right, so radical 28, we could break that down into radical 4 and then times, radical 7 would be my leftover, and then -1 would be my negative separated out of it. Right? So this part would turn into 2 times radical 7i. Nothing to do here, so just bring that guy down, bring this guy down, and then this we could at least break into radical 7, radical -1, and so we would keep the radical 7. That's going to turn into I, and then I'd bring my sign down. Right? So in terms of like terms, any just real numbers hanging out, those are like terms. We'd have -4. And then in terms of radicals, if you can remember back to when you did this in Algebra 1 and in geometry, you have to have the same radical or the same radicand to be able to combine them. In this case, since they have radical 7 and I can only combine that with other terms that have radical 7 and I. So those are like terms. The number in front here is just a 1. So then it's 2 minus 1, which means you just end up with a plain old 1 radical 7i. You don't really have to show the 1 in front, but I do want you to recognize that to be able to add radicals, they need the same radical there, and then you're only adding or subtracting the numbers in front, right? So you need the same radical to be able to add or subtract the numbers in front, which typically we call the coefficients, but sounds good. All right, let's switch it up. We did some simplifying, we did some adding and subtracting here. Let's do some multiplying. All right. First one here, I'm going to give you 5i and then times 6 minus 3i. I want you to treat this like it's a plain old, just algebraic problem. Imagine those are x's, all right? So if this was 5x times 6 minus 3x, we would just distribute. That's what we're being shown to do here. So first step would simply just be to distribute through. So we would get 30i, and then this would be 5 times 3 or 15. I times I would be I squared. And so as a general rule, any power of I that's greater than 1 needs to be simplified. So you might have noticed in the day 1 notes, everything came down to either be a positive or negative I, or it came back to be just positive or -1. We're never left with like an I to the 7th. That can be broken down further. So here, I squared, if you remember, that's the same as -1 because I itself is the square root of -1. So then if we square it, the square root and the square just cancel. And so I squared is -1. If you didn't remember that, you own a calculator, you can do I squared on your calculator. And so this is just going to be 30i and now plus 15. And then if we want to get particular, we can flip the order to make it in a plus bi form. There we go. So 15 plus 30i. All right, we got a couple more multiplying examples here. So let's flip it on over. Let me slide my paper down. So second one, I'm going to give you 3 plus 2i and then times 2 plus i. When we have binomial times binomial, there's multiple ways you can do this. One way, if you know what I'm talking about, would be to FOIL. It's a little acronym to say multiply the first outside the inside the last terms. Most people don't know it that way. They know it as the box multiplication. Now, I'm not going to fib. When you get into like pre-calc, they like for you to be able to do more of this in your head. But for now, I'm perfectly fine with doing some box multiplication. So it doesn't matter which part goes on which piece of the box. You just got to get it written out. So you could have like 3 and then plus 2i here, and then 2 plus i here, or vice versa. All right, when we multiply the pieces, 3 times 2, that's 6. 3 times I is 3i. 2 times 2i would be 4i. And then last, 2i times I would be 2i squared. So we get 6 These are like terms because they both have a single I, so plus 7i, and then plus 2i squared. And then like we said in the last part, any power of I greater than 1 needs to be simplified. So that's really a -1 there. And so then this becomes -2. And then 6 minus 2, we get 4 plus 7i. Cool. So just don't forget, you're going to have to make that little substitution here. Otherwise, it's nothing more than just kind of some practice with multiplying polynomials, which we did earlier in the year. That was actually some summer homework stuff. All right. This next one, you have 2 plus x times I, quantity squared. So remember, when you are squaring something, that is the exact same as just multiplying it by itself. So this is really 2 plus xi times 2 plus xi. So I'm going to do the same thing. We're going to do some box multiplication here. Give yourself a little bit of space. If you want to try foiling, go for it. I can always walk you through that in class if you're interested in seeing what that looks like. So 2 times 2, we get 4. This would give us 2xi. Here's another 2xi. And then this would give us x squared I squared. All right. We get 4. Here's a total of 4xi. And then plus x squared I squared. Again, I squared is the same as -1. So we're going to put a -1 in there and multiply it by the x squared. So then this really is 4 plus 4xi minus x squared. Now, if I said write it in terms of, real and imaginary, any part that doesn't have an I attached to it is considered the real. Any part with the I attached to it is the imaginary. So when we think A plus BI, that's what we're talking about. So here, no I is attached to those. That would be the real portion of this. So 4 minus x squared, that would be your A. And then plus 4xi, that would be your BI. So if you ever see a question where it says, which part is the real part? Then it would just be this. If it said, what part's the B? It would just be the 4x over here. So you might be asked to kind of dissect the answer and be able to identify the different pieces of it. All right, we only have one last quick thing to chat about here, and then you guys can be done with this video. And that is to talk about conjugates. All right, the conjugate of any binomial just means that you keep the terms and you switch the sign. So let me write it as this. We're going to keep the same A and B values, but switch the sign between. So in general, as a rule, if I have an answer that's in A plus BI form, its conjugate would simply be A minus BI. And this is going to be helpful in the future when you're trying to simplify rational expressions and all sorts of things. It's a little more pre-calcy, but it's like a little precursor to it. So for right now, if I just said, here's an example, 2 plus 7i, there's a complex number. What is the conjugate? I would expect you to look at that and say, okay, A, B, keep those guys the same, and then switch, oops, just kidding, switch the sign in between. So it would just look like that, right? And then same type of thing as if I said, here's -3 minus, 4i. What would be the conjugate, right? Well, keep the negative out front and then keep the 4i, and we're going to switch this piece of it to plus. All right, so it does feel a little bit like you're switching the B value, but I just mean keep like the number itself. So if this is a 4, I keep the 4 and I just flip-flop the sign in between. So if I ask you then to find the product of, let's say, 2 plus I and Oops, no apostrophe there. Oh, geez. Just have it. And its conjugate, I'm testing two things. Do you know what the conjugate of 2 plus I is? And then can you take the product or can you multiply them together? So 2 plus I and then times something and then see what you come out with as an answer. That is your post video question right there. So think about it. What's going in here? And then ultimately, when you multiply it all out, what do you get as a final answer? That's what I want to see, the final answer as your post video question. All right. Thanks, guys, for watching.